What's up guys, it's Simon Fiaz, and today's video I will be going through AQA level chemistry paper 1 June 13th of June 2017 question 1, and this will be a separate whole playlist going through all A level questions, and inshallah if God wills, if Allah wills, I will have this whole playlisting done by end of December, so maybe start of January, and same with AS level papers as well. But probably just A level papers, but if I'm pushing myself then I'll do both, and AS level papers, and then from beginning of January just spec papers, other kind of papers. I may be reviewing these kind of papers because past paper questions do repeat themselves, especially in chemistry, a couple of times. So first question, and before I continue, I won't be able to answer every single question, so I will skip a couple of questions since I haven't covered it in class, and that's it. So first question, define enthalpy of lattice formation. Well, let's type this out. Enthalpy of lattice formation, keep spelling it wrong, is the enthalpy change when 1 mole of a solid ionic compound is formed from its gaseous ions. Enthalpy change when 1 mole of a solid ionic compound is formed from its gaseous ions. Just a definition question for 2 marks, pretty nice. 1.2, some enthalpy change data are shown in table 1. That's the units, so I'm going to include that. Use the data in table 1 to calculate enthalpy of lattice formation of silver iodide. Well, first things first, we're going to use Hess's law cycle, and so we know we're going from silver iodide, just one I solid, to its separate ions, so Ag plus aqueous plus I minus aqueous, Ag plus aqueous plus I minus aqueous, and we know that we've got the gaseous ions, that's the aqueous ion, we've got the gaseous ions on the bottom, so Ag plus gas plus I minus in gas, and we know it is a lattice formation, so the arrows will point upwards. So a lot of constructing these cycles is learning key rules and just practicing it a bunch of times. And I'm going to be honest, this is one of my weak points in chemistry, constructing Hess's law cycles. So yeah, just keep practicing if you guys don't understand it. So you're going from silver iodide solid to its ions in aqueous, it should be minus there, and we know we got the ions in the gaseous state, and we know that it takes 112 plus 12 to go from silver iodide solid to its ions in aqueous, and we know to go from its gaseous to its aqueous is minus 464. So here's the gaseous, there's aqueous, minus 464. And we also know to go from the I minus in gaseous to I minus in aqueous, it's minus 293. So if we add that up, minus 464 minus 293, not add it up, we'll get minus 7, add it up, minus 757. And basically now we're trying to find lattice enthalpy of formation of silver iodide. So from here to here, we're trying to find this. Now how do we go from here to here, from here to here? Well, we can go this way and then this way. So we already know this way is minus 757, so it's going to be lattice enthalpy of formation, lattice enthalpy F formation is going to be minus 757 plus, well, this 112 is to go from its solid to its aqueous. We're trying to go the other way around. We're trying to find its solid, so it's going to be not plus 112, minus 112. And if we put that in a calculator, we should get minus 869 kilojoule per moles minus 1. And I thought they were going to trick us out by not giving us units, but yep, it's already units already there. So for 2 marks, pretty hard 2 marks in my opinion, but the more you practice Hess's law cycle, the easier it becomes. So next question, 1.3. A calculation of the enthalpy of lattice formation of silver iodide based on a perfect ionic model gives a smaller numerical value than the value calculated in question 1.2. Explain this different. Well, a perfect ionic model is the idea that it's completely symmetrical, so it's got to be something about the silver iodide, because we know a calculation of lattice formation of silver iodide gives a smaller value than the value calculated. Why does it give a smaller value than the value calculated in a perfect ionic model? Well, it's because the AgI, silver iodide, actually I'll just type this in, it's better to type in, I'll just type silver iodide contains covalent character. That'll give you 1 mark. Hence, the forces holding lattice together are stronger. And that's for 2 marks. And question 1.4. Identify Rudiger used to identify present iodide ions. Iodide ions AgNO3, silver nitrate. And what precipitate is it? Well, it's obviously going to be a yellow precipitate. So you can see already in question 1 we've got 2 marks for just our knowledge and another 2 marks for just our knowledge. So make sure you learn your definitions and your key details, because half of the marks on this first question is just AO1. And that is the end of question 1.